Come to section 4.2, max min values. So what we're going to do here is we're going to be asked to find absolute max or min values of a continuous function in a closed interval. I'll give you a few steps that we'll follow, and then we'll do a couple of examples. So basically what we'll do is we'll find our critical numbers, we'll figure out what the function equals at those critical numbers, we'll find the endpoints of our interval, f of a, f of b, and whatever the lowest of all those is our absolute min, and whatever the highest is our absolute max. Kind of makes sense logically, and especially if you see it with a real example. So for us to find the absolute max min for this cubic function x cubed plus 1.5 x squared minus 60x plus 11, defined in the interval from -6 to 6. So first of all, I find the derivative. My derivative is relatively easy, 3x squared plus 3x minus 60. I factor that because I want to figure out what the critical numbers are. So I've got 3x plus 5 times x minus 4. And so if I make that equal to 0, I find that my critical numbers are x equals -5 and x equals 4. So those are the only two critical numbers for this function at all. They do both fall in the interval we're talking about. And so really I just look and I say, what's f of -5? What's f of 4? What's f of -6? And what's f of 6? Because those are the ends of our interval, and whatever the highest one of those numbers is my max, and whatever the lowest one is my minimum. It takes a second to crunch those numbers. Grab your calculator, put -5 into the original function, and you get 223.5. Do the same thing for 4, -6, and 6, and you find that the highest point, so your absolute max, is at -5, 223.5. That's the highest this graph goes anywhere in that interval. And the absolute min is the lowest it goes anywhere in that interval, which happens to be at 4, -141. So as long as you've checked your critical numbers and your end points of your closed interval, there's nowhere else that your max or min will be for a continuous function. So let's do one more example like that. Let's find the absolute max min for this function, and in this case only from the interval -5 up to +1. So the first job again is to take the derivative, but if I were you, rather than use the product rule here, I would say, well, g of x equals 5x to the 2/3 plus x to the 5/3, multiplied out first. So my g prime equals 10/3 x to the -1/3 plus 5/3 x to the 2/3. Hard to see critical numbers when it's written that way, so written in a factored form would be to take out whatever common factor you can, take out the 5/3, take out x to the lower of the two exponents, and it leaves me with 2 plus x. Well, now I can see that x equals 0 would make this thing undefined, because if you have 0 to the -1/3, that'll be a problem, and x equals -2. These are my critical numbers. So I'm going to see, what does f of 0 equal? What does f of -2 equal? And of course the ends of our interval, f of -5 and f of 1. So I'm putting this into the original function. 0 is going to give me 0 because I have 0 times 5. -2 in there is going to give me the cube root of 4 times 3 times the cube root of 4, whatever that would be in decimals. Kind of ugly one. The next one gives me 0, and the next one gives me 6. So I really just need to decide whether the cube root of 4 times 3 is higher or lower than 6, and I'll be able to answer my question. So let's figure out what the cube root of 4 is, times 3. That's about 4.76, so definitely not higher. So my absolute max is easy, because it happens at 1,6. My absolute min is kind of a weird one, because we have a tie, basically. We have 0, 0, which is exactly the same value of the function as -5, 0. So you can have a tie for your absolute min. But the idea here is the same. Take your derivative, find your critical numbers, where is your derivative undefined or 0, and then try those to see which one is your absolute max, absolute min.